So in the last session we have seen what feature selection is, and also we highlighted that there are three methods of selecting the features: filter methods, wrapper methods, and embedded methods. Let's get in detail one by one. So first let us look at filter methods of feature selection. It involves selecting a subset of features based on their statistical properties or scores without incorporating any machine learning algorithm. So here what we do, we just try to apply some statistical process and see the correlation between the feature with the outcome. So one of the best way to solve this is using p-value of any parameter. So apply the statistical process of finding p-value and see whether any parameter has any correlation with the outcome. If no, then can be filtered out. So one of the easiest way is use a hypothetical testing. So test for a p-value, and then if p-value happens to be less than the threshold, then we can just eliminate that. The next one is variance thresholding. So find out the variance of the parameter, variance of the feature, and if the feature is not varying much or varying much, so we need to understand the variation in the feature means what with respect to the problem solving, and it uh, involves understanding the variance and see how much variance of any feature is, then apply threshold and filter out. Then we can use the correlation based feature selection. That means try to use correlation among the features. If we find the correlation among the features, that means these features are some way related to one another. That means only one of them can be retained, all others can be eliminated because they are unnecessarily increasing our data set without contributing any more information. So one is sufficient, rest all can be removed if multiple features are found correlated to one another. On the other side, look at the correlation between the feature and the outcome. If feature has no correlation with the outcome or the outcome has no correlation with the feature, then that feature can be filtered out. So it can be univariate feature selection. So one time one feature is used, then we can look for information gain and see which feature has got maximum information with respect to the output or mutual information among the features. So using this we can find out what all features are required, what all features are useless, so we can filter them out. Then we can use chi-square test, we can use ANOVA or select K best are some of the algorithms available for selecting features that can help us in improving the model efficiency and at the same time reducing the time and space complexity of the training process. The second set of methods is called wrapper methods. So this involves evaluating different subsets of features by training a machine learning model on them and selecting the subset that results in the best performance according to the chosen evaluation metrics. That means in the previous case we had no machine learning involved, but now we have machine learning involved. So what we can do is instead of using all the features together, we can take subset of features while training the model and then look at so which subset of features can give better results. So there are methods like forward selection. So we start with one feature, train it, check the performance, and then add another feature and check if the new feature added will improve performance or not. If not, then remove that, add another one. So that way we start with the unique features, then pairs of features, then triples of features or quadruple features together and so on. So this way we keep adding number of features one by one and see which combination of the features will give the best result. Yeah, of course, it is too time consuming and too complex process. Other way would be backward elimination. So instead of starting with a single feature, you start with all features and then start eliminating one by one till we get a best possible solution. Or it can be a recursive feature elimination or recursive feature addition. So this whole process can be forward selection, backward elimination processes can be automated so through recursive way, or even we can look for bidirectional search. We can use the genetic algorithms or sequential feature selection algorithms for selecting the best combination of the features for getting the best overall performance of the model. And the third set of feature selection methods is called embedded methods. It involves performing feature selection as part of a model training process. So here what we do is we keep all the features during the training process, but to that we attach a regularization factor to that. That means every feature will be uh, multiplied with the coefficient, and this coefficient is going to uh, make sure how much component of that feature will be used for training. So that's what we call regression or regularization. So there are basically two types of regularization: the L1 regularization, also called lasso regression, and L2 regularization, which is also called ridge regression. So L2 is something to do with the uh, Euclidean distance, and L1 is the Manhattan distance. So here the coefficient of every variable is updated, but the problem with ridge regression is the coefficient is reduced to minimum so that its contribution is not available much to the overall result, but still it is not zero. So when there is some coefficient, we need to multiply with that. So that's product and all that will be computed. But whereas it comes to lasso regression, the coefficient can be made totally zero, and because of this we can just remove that feature from the computation at all. So that way the lasso regression or L1 regularization gives a better results compared to the ridge regularization or L2 regularization. But each one has got their own pros and cons. So the pros is lasso coefficient can become zero, therefore we can just neglect that component and continue processing, whereas ridge cannot make it zero. So its presence will be there, but will be in a small magnitude, but still it will be there. So if we want to have both the pros together, then we can go for the third one, which is an elastic neck, which is combination of both L1 L2 regularizations together. So that's one option. The next thing is we can go for tree based methods for embedded feature selection, or we can also use sparse support vector machines. We can go use neural network pruning. So these embedded methods are advantageous because they select the features while simultaneously training the model, which can lead to improved performance by focusing on the most relevant features. So looking back, the first one, filter method, it's part of the pre-process. So lot of processing we need to do before actually training the model. The second one was one where the wrapper method is one where combination of features are used to train. That means we are training the model multiple times and then the best model is used. Whereas here only one model is being trained and no pre-processing like filtering method, no combinations separately. All the things are put together, and these contribution of each parameter is modified through regularization, and that effect is automatically done during the training process, and hence this embedded method of feature selection gets a maximum votes when you are trying to choose. So because that's one which gives best performance with a single round of training, and no much pre-processing as required in filtering case, no multiple training as in wrapper case, but single training and selections and all are done automatically. So that's some details about the feature selection.